Hello everybody, we're looking at lesson 34, which is congruence via rigid motions. So for this one, what's going to happen is two different types of motions will happen, and you're going to need to look at them, think about what type of motion it is, and then decide if it can prove congruence or not. So this is good review of everything. So remember, look at the different options. A reflection, that's when something flips over something else, flips across the x or the y-axis. Rotation is when something spins in a circle. Translation is just moving up, down, left, or right. Dilation is if it stretches or shrinks. So let's look at what happens here. What's the first motion that happens? They show it in order. So it's starting over now. There it goes, from the beginning. It spins around like that, and then it slides down. So first, what is it called when you're spinning like that? That would be a rotation. And then once I select rotation, I need to say what kind. So it's spinning about the origin. Origin is the center, and it's spinning. First off, if you're doing a circle, 360 is a full circle. 90 degrees would be a quarter of a circle. 180 is half of a circle. 270, 3/4 of a circle. 360, full circle. So it spins how much? That looks like 180. And is it going clockwise or is it going counterclockwise? So think about a clock. A clock would spin like this. Counterclockwise would spin like this. So it's going counterclockwise. So it's a rotation that's 180 degrees counterclockwise. 180 degrees counterclockwise. Followed by look what it does, it slides down 1, 2, 3 places. Notice what I'm doing. I'm looking at the upper left point to the new upper left point. So followed by a translation is what we call just simple motion. And up or down, down, and it's going to be 3 units. And then the last thing, is this figure congruent to that figure? Well, look what happens when we do all of our motions. Are they the exact same shape? Yes, they are. So the two figures are congruent because only rigid motions are used to map figure D to figure E. Notice we didn't stretch or shrink. We took the exact same figure and we just moved it over until it was figure D was where figure E was. And let's see if they're happy with that answer. Yeah. Let me do one more. I've made it so for this one, you're going to need to do 3. I've made it so there's no penalty if you get anything wrong. So you don't have to get 3 in a row. Just get any 3 right. So you can keep trying until you get 3 right. Okay, let's see what's happening here. Okay, so it rotates over to there. And that would be so first thing's a rotation. It's going in this direction, which is counterclockwise. And again, it spins a half of a circle, 180 degrees. So it's a rotation of 180 degrees counterclockwise, followed by a translation, and this time it's up here and it goes down 1, 2, 3, 4, 5. Down 5 units. The two figures are congruent because only rigid motions are used to map one to the other. You know what? That was almost identical to the other one. Let me see if the next one's any different. Okay, here we go. So look at what happens here. So look, it shrinks. So first we have a dilation centered at the origin, meaning the origin is the center. Let's look at how much does it shrink by. What I'm going to do here, I'm going to count this long side on the big version of it, and then the long side on the small version of it. So it's going to be, oh, you know what? That won't even work because it's not lined up on the boxes perfectly. But if you look at it, compare them. What do you think the size difference is from the big one and then the small one? It does make it a little bit difficult due to the fact that you cannot just count across. But if we were to measure that, here's what we could do. I'm gonna go. It's 1, 2, 3. So to get from the bottom left to the upper right, you would go over 1, 2, 3, and then up 1, 2, 3, 4, 5, 6. Now look at the new figure, the small figure. You would go over 1, 2, and then go up 1, 2, 3, 4. So basically, it's like a shrink. It was 3, and now it's 2. So a scale factor of 3 over 2. I'm sorry, 2 over 3, because it shrinks. 2 over 3. 3 over 2 would be 1.5. That would be making it bigger. 2 over 3 means it's making it smaller, followed by so you shrink it to 2/3 its size, right? Doesn't this little guy look 2/3 the size of the big guy? Yeah. You know what I should have done? This would have been easier. Look at this side. This is lined up. This is the side I should have paid attention to. Look how it's lined up. It's 1, 2, 3 tall. This side is 3 units tall. How tall is this side? 1, 2 units tall. So it goes from 3, shrinks down to 2. That would have been much easier than what I did over here. So it shrinks 2/3 of its size, followed by a translation. So it's here, it goes up 1, 2, 3. Look at this one, 1, 2, 3. So translation up 3 units. The two figures are not congruent because non-rigid motions are used to map figure T onto figure U. Because first we had to do a dilation where we shrink it. And we're right, okay? So that's what we'll need to be doing. So do your best on this. If you need any help, have any questions, just send me an email. And have a good rest of your day.